This is the second part of the video for LinkedList. If you haven't watched the first part yet, then go back and watch it. Otherwise, you're going to be lost on this. So here we have our very simple LinkedList, but we do not want the main program to do that. We're going to create a LinkedList class that is going to take care of all the inserts and traverse. So let's create a class. And I'm going to name it my LinkedList. I'm going to the class view, and on LinkedList class I'm going to add a function, no returning type, and the function name is going to be insert, and it's going to receive some kind of data. And I'm also going to add another function, void returning type, and this is going to be called traverse. And with this function we're going to just print all the items that we have inside the LinkedList. So let's work on the insert first. So the insert is going to receive an integer data, int data, and I'm going to create two private members here. One is going to be the head of our LinkedList, or the root. Let's call it head. So node head. I forgot to include the node here. So node head, and I also want a tail this time. Now let's implement the insert function. The constructor, the only thing I want on the constructor is to get the head and make equals tail. And the reason I'm doing that is because create two pointers, and if the head happens to be equals tail, then guess what? There is no LinkedList. So that's going to be a way for me to identify that the LinkedList is empty. So head equals tail. So let's insert something now. In order for us to insert, we need to create a node. So let's create a node. Node equals new node. Node, the data of the node equals the data that we're passing here. This might be confusing, so I'm going to change the data here. So instead of putting data, I'm going to put underscore data just to differentiate. So underscore data, just so that's not confusing. And then now I create a node, and this is something like this. So I created the node, but now I need to point the head to this node. We need to find out first if the LinkedList is empty or not. And the way we find out if head equals tail, we know it's empty, else we know it's not empty. There's at least one node on this linked list. So if it's empty, I'm just gonna put a message here. On head. Oh, I forgot the IO stream, didn't I? Yep. Okay, let's include the IO stream. So if the linked list is empty, I'm going to put a message here. First item. Otherwise, I'm just gonna put here not first item. And that's just by curiosity. I want to know if it's working properly. You don't really need this message here. So if it was empty, now we need to get the head and point to the new node. So let's get the head equals the node. That's all. So with this line here, what we're doing, we're changing this to this. And now we know that head is pointing to node. And now we need to get the node and point it to the tail. So node next, now pointing to tail. So we now have something like this. Now if it's not the first item, then we just get the node next and point to head, and then we get the head equals, and then we get the head and point to node. So if that was the first item, we did this. If it's not the first item, then and point to the new one. So that's all we have now. Go back to the code, and the function for insert is now completed. It's quite simple. And the traverse is also very simple. We're going to create a temporary pointer of my node, and we're going to point to head. So node, it's going to be a temporary node, and it's going to be equals the head. We don't want to change the head, we're going to change the temporary. And what's going to happen is, as we traverse this linked list, the temp node, so the temp that we created, we point it to head. We're going to do whatever we want to do, and then after that we're going to point to the next item, do whatever we want to do, and point to the next item, and so on. And then eventually when temp equals tail, we know that we got to the end of the linked list. So let's go back to the code and write this. So temp now points to head, and then we're going to write a while loop, and while temp not equals to tail, we're going to print whatever temp points to, and we're going to get the data inside that that node, and then now temp will get temp next. So printing the data, and then temp is going to point to the pointer that the current node is pointing to. So first temp was equals head, and then now temp is equals this pointer here, because I want to move to the next item. And then on the next loop, this temp will be then equals this pointer, so I can move to the next node, and so on, so on. So with that, we're done with the traverse, and we're also done with the insert. Let's go to the main, and I don't want to do all this work here anymore, because now I have a class to do that for me, and the class is my LinkedList. So let's use this object here. So my LinkedList, and ll.insert. If you guys remember, it was an integer, so I'm gonna pass 10 here, and then I want to insert more items, like 20, 30, and a 40, and then after that I want just to traverse the LinkedList. So let's see how this works. So if you remember, there was the first item, so insert it into the head, 10, and then it was not the first item, and then start inserting. So now we end up with 4 items, and then traverse just prints whatever you have in your LinkedList. Now I understand that this LinkedList is very, very simple. You can get very fancy with LinkedList, but this is just the starting for you to understand how this work. And on the next video, we're gonna get a little fancier with LinkedList.